Okay. Next week we will have online class on Tuesday and Wednesday. Okay, Tuesday and Wednesday we will have online class. For this week, Thursday and Friday. Are you still here Thursday? No. Oh, going back. Okay. Okay. I can have online class for Thursday and Friday. And also next Tuesday. Okay, next Tuesday, last section 2. Okay. Okay, now we continue to our this complex numbers. Okay, this is a new chapter, as I have mentioned in the first class. This complex number is not going to be covered under any of your assessment. That means this will not be covered under final exam, quizzes, assignment, midterm. But why you still need to learn this one? Because this will be used in your next semester subject, electrical circuit 1. Okay, electrical circuit 1. For this chapter, I don't use my slide. I use this appendix. Okay, this appendix is actually taken from the subject of the electrical circuit 1. Okay, because feedback from the lecturer who teach that subject, many students do not know how to do this. Okay, so I use the attachment. Okay, this one under the electrical circuit 1. Okay, and I hope it helps in your next semester. Okay. Okay, so this one, complex number. I think you know what is a complex number, right? The complex number, it contains the real part and an imaginary part. Okay. This one. Normally, we will denote a complex number by Z. Okay, Z equals to X plus JY. X is the real part. This one, X is the real part. So we write this real part RE and then Z. Z does mean this complex number. The real part of this complex number is X. Okay. And the imaginary part, IM, imaginary part of Z is Y. Okay, this one Y. Okay, this one we use notation J. The one with J is the imaginary part, including the sign here. So if this is a minus, this will be minus 1. We don't take the J, okay, the imaginary part, we just take the coefficient of J. Okay, we don't take the J here. J is just the not. That is the imaginary part. Okay, so if we have a minus, take together, this will be minus 1. And what is J? J is actually sub negative 1. Okay, sub negative 1. So when you have J squared, the square of this, what do you get? The square of sub 1, of sub negative 1 is negative 1. Okay, negative 1. J square is negative 1 because the square of this is power of half, right? This is negative 1 power of half. When you have a square, that means we cancel out the square with the half. Okay, the half is a square, then you have negative 1 power of 1. Okay, J square, remember J square is negative 1. Okay, and so on. J cube, you have negative J to the power 4, that means 1. Okay, j to the power 4, that means this 1 square. You get 1. Okay, this one, j cube, why we get negative j? Because j square is negative 1. Negative 1 times j, you get negative j. Okay, so you just need to know j is third of negative 1. So j square is negative 1. Okay, complex number, we can sketch the complex number in this form. Real part. This is real part. So the real part is x just now. Okay, x is real part. This one. That's why this is x. This is imaginary. Okay, I am imaginary. That means jy. Okay, positive. Positive. That means above this axis, jy. Okay, so that means the length of this is x. The length of this is y. Okay, the length. Okay, y. And we have a data here. Okay, this is the data. So from a complex number, you need to find for the r. Okay, r, that means the distance. The distance from that point from the origin. That is r. And the data, that means this is the data. Okay. Okay. This one, this complex number is presented in rectangular form. We can express the complex number in polar form and also exponential form. There are 3 different types of form. This is called rectangular form. This is called polar form. Okay, polar form. And one more exponential form. Okay, later only we look at exponential form. We look at the polar form first. So this is the complex number z equals to this. So r we can obtain from this one. Okay, because r is the distance from the point from the origin. Okay, so we use this formula to get for r. Okay, we square the x, square the y, we sum them out in the square root. Okay, and for the data, okay, data, this one I need to write on the board. Okay, so this is r. This is your data. And r is square root of x squared plus y squared. Okay. And data. If you look at this triangle, what is tangent data? What is tangent data based on this triangle? So the length of this is y. The length of this x. Tangent data is opposite over x. So your data is 10. Here will be arc 10. Arc 10 y over x. Okay, that's why you have these two. Okay, then you can put them into the formula. This is polar form. That means given a complex number in rectangular form, you can find for the r, find for the data, put these two into this form. This will be polar form. Okay, this is a symbol that carries the data. Okay, this is polar form. Okay, there's another one, exponential form. Exponential form is r, e, j data. Okay, so with the r, information of r and information of data, you just put these two into this form, then that is exponential form. Okay, exponential because of this exponential. Okay, and here you must have a j. J data. Okay, now I want to show you how to get the data from different quadrants. Okay. So this is the first quadrant. Okay, this is the first quadrant. That's why the data is arctan y over x. Okay, if we look at the second quadrant, okay, second quadrant, let's say this is negative x. Okay, negative x, and here is y. So the data, okay, the data is this one. Okay, let's say I call this as alpha. Okay, let's say I call this as alpha. So from this triangle, we find for the alpha first. Then we use 180 minus alpha, then we get data, right? And we look at, we find for the alpha first. So tangent alpha is y over x or negative x? X. We are talking about distance. Distance. The distance is y. The distance is x. Okay. This one is distance over distance. So we don't take the negative. We just take the magnitude, the length. Okay, the length. So y over x. So that's why your alpha is arctan y over x. So your data would be 180 minus the alpha, right?
Right.
Okay, next one. This is second quadrant. The third quadrant is here. Okay, this is the third quadrant. Okay, let's say this is negative x, this is negative y. Okay, negative y, a1. Okay, your data will be this one. Okay, your data will be this one. So this is your alpha. This is your data. Again, we find for the alpha. Your alpha is arctan
X.
distance. Y. Distance y over x. Okay, this is alpha. So your data will be 180 plus this. Okay.
Yeah.
Okay, last one. Last quadrant. Okay, last quadrant. Let's say this is alpha. Your data is here. Okay, let's say this is x. This is negative dy. Okay. So what is the alpha? Arctan. Opposite is distance y over distance x. So the data is okay. For the fourth quadrant, there's another way to present the data. Okay, if the direction of this data is this, it will be positive. If it starts from here, goes in this direction, it will be negative. Negative. So it becomes something like this. If this is like 45, if this is 45 degrees, so this one alpha will be, okay, we can say that this is not alpha. Data. Data, this is alpha, let's say. So alpha negative 45. Negative 45 degree, that means it starts from this and it goes into this direction for 45 degrees. That is negative. Okay, negative. Okay, back to here, this one. So we can also say that the theta of this is negative alpha. Negative alpha. So that means negative arctan y over x. It can be this one or this one. This one with a negative sign. Because it starts from this direction. Negative. Okay. If you use the calculator to try, you see that this figure is the same with this figure. They are the same. Okay, so these are 4 different quadrants. Okay, with how to get their data. Okay, any questions for this one? So that's why for the first quadrant, your data is alpha, okay, arctan y over x. For second quadrant, you use 180 minus alpha. Okay, for the third quadrant, you use 180 plus alpha. And the last quadrant, we use 360 minus alpha. Okay, and you see that this one, we don't take negative sign. Okay, we don't take negative sign, even though we have negative here. Okay, we have negative here, but we don't take the negative sign because we are looking at the distance. Okay, we look at the distance. The minus sign here is just letting us know where is the location. First quadrant, second, third, or fourth of that complex number. Okay, so this is the exponential form. Okay, exponential form. Okay, so these are the 3 different forms. Rectangular form, where, okay, this one I will show you. Okay, this one. Okay, just now, we said that this is R. Okay, R is the length, okay, of the set from the origin. And what is cos theta? What is cos theta? Cos is actually this is x. Okay, this is y, right? So x over like what sentence r. So what is x? Yes, we move the r to here, so you get r is form r cos theta. R over here, your x will be r cos theta. And sin theta, what is sin theta? Y over r. So your y is r sin theta. So this is how we get these two, huh? X is r cos theta, y is r sin theta. Here, this one. Okay, this one. X is r cos theta, y is r sin theta. Okay, now we look at the examples. Z1, okay, Z1 is 6 plus J8. Okay, so this falls in the first quadrant. 6, 8, first quadrant. So we find for the R. Okay, R is the square root of you square this 6 plus square the 8. Okay, you get a 10. Then your theta, since this is in first quadrant, so your theta will be alpha. The alpha is up 10, 8/6. Okay, the y over x. And this one, they use degree. Okay, so your calculator in degree. Once you get the r and theta, okay, what it wants? It wants you to express this in polar and exponential form. Okay, so in polar form, it will be r, and then this notation carries the theta. So this is the polar form. And the exponential form is r from here, r, e, j, theta. That's it. As long as you know how to find r and theta, you know how to change the form of a complex number. Okay, next one, Z2. Z2, this one, 6, okay, 6, -8. That means the last quadrant, right? The last quadrant, the fourth quadrant, we find for r, okay, so the square of 6 plus the square of -8. If there is negative, okay, this will be negative. Okay, but after square, you get positive. Okay, and you get 10. In the fourth quadrant, you use 360 minus alpha. Okay, your alpha is up 10, 8/6. We don't take minus. So this one minus alpha, you use your calculator, you get this. Okay, once you get r and theta, you put into this, you get polar form. Okay, r theta, or exponential form. Okay, r, e, j, theta. Very simple. And since this is falls in the last quadrant, we can also say that the theta is negative up 10, 8/6, right? Negative alpha. Our theta can also be negative alpha because it falls in the last quadrant. Okay, if you use negative alpha, you will get this negative 53.13 degree. So if this is your theta, this will be your polar form. And this will be your exponential form. Okay? Okay, next one, this one. -6, 8. That's mean second quadrant. Second quadrant, okay, find for r and then theta. For second quadrant, we use 180 minus alpha. Okay, minus alpha. Then substitute r and theta into polar form and also exponential form. Okay, for the last one, third quadrant, okay, find for r. Third quadrant will be you need to plus a 180 to the alpha. Okay, once you get r and theta, okay, this is your polar form. This is your exponential form. Okay, now we try this exercise. We try this. Okay, the answer is already given here. Okay, try this. Okay, so what do we get? R? 5. 5. Okay, then which quadrant it falls in? Which quadrant? Fourth quadrant. You have to know which quadrant it falls in. This one, see, 3, positive 3, negative 4. Negative 4 is here. So this is fourth quadrant. You have to know which quadrant it falls in, then only you know how to get the data. Okay, so fourth quadrant. The data will be use 360 minus alpha. Your alpha is up 10. What is your alpha? 4 over 3. Okay, 4 over 3. We don't take the minus here. Just take the distance, the magnitude, 4 over 3. Okay, use your calculator. Okay, you should get a 306.9 degree. Okay, degree, use degree. In the electrical circuit one, they use degree, so you have to follow use degree. 306.9 degree. So the polar form is R, then a symbol like this, and 306.9 degrees. This is polar form. And the exponential form, this is Z. Z equals to R, E, J, theta. Okay, exponential form is R, E, J, theta. Whether sign for your attendance. To which quadrant? First, the data is the alpha. The alpha will be up 10, 12 over 5. You can get from England. Okay, second three, which quadrant? Okay, third one, that's mean we have to plus 180. Okay, to the alpha. Our alpha is up 10.
I'm done with you.
Okay, last one, B. Which quadrant? Second. Okay. -7 and then +1. Second quadrant. Second quadrant is 180 minus alpha. Okay, the alpha is up 10, 1/7. Okay, any questions? Okay, next, we look at how to convert the complex numbers from exponential and also polar form back into rectangular form. Okay, so this one, if we want to convert the complex numbers from polar or exponential form into rectangular form, there are two information that we need. We need the R and theta. Okay, we need R and theta. So we know what is R, we know what is theta, then we can convert it using this formula. Okay, this one. To get X, we use R cos theta. To get Y, we use R sin theta. Okay. Now we look at the first example. Okay, so R is 12. Okay, so R cos theta. R cos theta, this will give you the value of X. Okay, plus J. Okay, this is imaginary part J. R sin theta. Okay, R and theta here. So R sin theta. So you use your calculator to compute 12 times sine negative 60 degree. Then you will get negative 10.39. Okay, this is how we convert the complex number into rectangular form. Okay, so similar to this B, we have the R, we have the theta. You just substitute this R and theta into R cos theta and R sin theta. Okay, this one minus just because of this. Okay, the one with sign, it has a J. This is imaginary part. So just use your calculator to compute, you get this. Okay. Similarly to the exponential form, we have the R and theta. So R cos theta, R sin theta to get the X and Y. Okay. R is 20, theta is negative pi over 3. Okay, negative pi over 3. So this one, your calculator is in if in degree, pi will be 180. If in radian, pi will be 5. Okay, then you will get this. Okay, you can try this one. Cos, your calculator is in degree, right? In degree, so this will be negative 180 over 3. That means negative 60. This is negative 60. If you use pi, you will get the wrong figure because your calculator is in degree. Degree, that means pi is 180. Get it? Okay. Next, this one, exercise. So your set will be R cos theta. Okay, this one we use this R cos theta plus J R sin theta. You just substitute the R and theta to get this answer. Maybe 8 cos 210 plus J, that means minus J 8 sin 210 degree. You should get this.
Dan ada yang susah sangat. Ada yang nombor kan? Dia tak fikir hari esok. Kita pakai rating,
Degree. So you have to use degree. You are given degree, right?
Yes.
This is the data is in degree, so your calculator should be in degree. Okay, if this is pi, okay, if you have something like this, 8, let's say 8 pi, when you say 8 pi, you can either use radian or degree. If your calculator, you want to use degree, you have to change pi into 180 degree. That means 8 times this. If you use radian, that means this is pi. Just use the pi from your calculator.
Wow, belajar. Gimana?
Okay, if we use degree, this will be 90 degree because 180 over 2. Okay, unless you use radian. If you use radian, it will be pi over 2. The cos 90 degree is 0. Okay, cos 90 degree is 0. Okay, any questions? Any questions for converting from polar and exponential into rectangular form? Okay, if no question, we continue. Oh. Okay, next we look at the mathematical operation. Okay, Z is a complex number. When Z, this one, is a complex number, we have R and then theta. Okay, but when we have a complex conjugate, it means we change the sign. We change the sign of the imaginary part. So, for example, there is an example here. Okay, when we have Z is x plus jy, your polar form is R theta. Okay, the complex conjugate, in this book, we use this as 3 to represent this is a complex conjugate. Okay, different books actually use different notation. In this book, it uses this notation to denote that is a complex conjugate. So the complex conjugate of this is x minus jy. We have to change the sign of the imaginary part. So this is the complex conjugate. So one, it will be R negative theta. Okay, complex conjugate. Okay, now back to here. If we want to sum, okay, we want to sum up two complex numbers, okay, we will perform this operation under rectangular form. Okay, under rectangular form. Okay, this one in rectangular form, this one, Z2 is also in rectangular form. This one, x2 plus jy2. So the real part plus the real part, you get this. Imaginary part, sum up with the imaginary part, you get this. This is how we do the sum. Okay, the sum of the two complex number in rectangular forms. Okay, and their difference is for the subtraction, we are using the rectangular form as well. We use the real part from the first minus the real part from the second. Okay, and same goes to the imaginary part. The imaginary part from the first minus the second one. Okay, and when it comes to the multiplication, okay, multiplication, this one. If we use rectangular form, that means we have to expand. Okay, we have to expand. Then we group the real part here and the imaginary part here. Okay, if we use rectangular form to run the operation of multiplication. Okay, and alternatively, we can use this. This is much easier. Okay, we can find the complex number in polar form. Okay, in polar form. So Z1 times Z2 will be R1 times R2, and we just need to sum up the data, two data. Okay, so these two are the same. It will give you the same answer. One is conducted under rectangular form. This is conducted under polar form. So this is easier. Okay, and same goes to the division. For division, if we run the division under polar form, it will be easier as this. Okay, Z1 over Z2, we use the first R divided by second R. And for the data, you use the first minus the second. But if you want to use rectangular form, this one, okay, you have to multiply. Okay, you have to multiply the denominator by the conjugate of this. Okay, so you see, we multiply this one. This is an extra thing. This is the complex conjugate from here. Okay, minus this is plus. Once you multiply this at the bottom, you have to multiply the same thing at the top. Okay, and why we need to multiply the complex conjugate at the bottom? Because Z times Z conjugate, it produces no imaginary part. We don't want to have imaginary part at the bottom. Okay, that's why we multiply Z with its conjugate. Okay, so you don't see any real part. There's no more J here. Okay, no more J at the bottom. Okay, so at the top, you just expand as usual and then combine. And after that, we will separate the real part and the imaginary part. Okay, so this is the same as this, but this is much easier. Okay, now we look at this example. Okay, all these examples conducted using the rectangular form. Okay, A given A, B, we want to find A conjugate times A plus B. Okay, so A conjugate is 2 minus J5. Okay, 2 minus J5. Then we find for A plus B. Okay, A plus B, confirm we have to use rectangular form. Okay, so this one plus real part, sorry, AB, this two. Real part plus real part, you get 6. Imaginary part, combined with imaginary part, you get -1. So 6 and -1. Okay, then only we multiply the complex conjugate with this. Okay, so this one times this. Here, these two. So these two, you expand like this. So these two, you get a J square. You have a plus J square 5. Okay, plus J square 5. J square 5. Remember, your J square is -1. J square is -1. That's why you have a -5 here. Okay, then real part with real part, imaginary part with imaginary part, you will get the final answer. Okay, so this is for A. Then B, okay, we find for A plus B and also A minus B. Okay, A plus B, we already got this 6 minus J. Then we find for A minus B. Okay, A minus B, Okay, real part minus real part, imaginary part minus imaginary part, you get this. Then a plus b, just now this is what we found, 6 minus j divided by this a minus b. Okay. So when you see a complex number over a complex number, if we use rectangular form, we have to multiply this with the conjugate of this z. Okay. So the conjugate of this is -2 minus j11 here. Okay, when you multiply this at the bottom, we multiply this, the same thing at the top. So if you look at the bottom, z times z conjugate, we will obtain x squared plus y squared. Okay, so the x squared is 4. Y squared is 11 squared. No more j at the bottom. Okay, when we multiply z with the z conjugate, no more imaginary part at the bottom. This is what we want. Okay, that's why we multiply the complex conjugate here. And at the top, you just expand as usual. Okay, expand, then you get this. Okay, the last one should be plus j squared 11. But j squared is -1. Okay, -1. That's why -1 times 11, you get -11. Okay, then real part with real part, imaginary part with imaginary part, you get this. And this is a complex number. You are not allowed to present your final answer in this form. You must separate this into real part and imaginary part. Okay, so that's why this one must be divided by 125 to get this, and this part divided by 125 to get this. You must present your complex number in the form of x plus jy. You can't leave it like this. Okay, this is not yet complete. Okay, now we try this. Okay, we use rectangular form. Okay, so y for c minus d conjugate. Okay, I write in one line. C. Okay, c minus, what is d conjugate? 8 minus j. Okay, this one times c plus d conjugate 8 minus j. Okay, simplify, then extend. Okay, real part with real part. -3 minus 8. Okay, -11. J7 plus J plus J8. Okay, -3 plus 8. 5. And J7 minus J6. Okay, so here you just expand. Okay, expand -55 minus J 66, and then plus J 40 plus J squared 48. And this J squared is -1. Okay. So we have -55 minus 48, and we get -103. -66 plus 40, we get -J26. Any questions? Complex conjugate, we just change the sign. Okay, we just change the sign of the imaginary part. Conjugate. Okay, B squared. Over conjugate. -3 minus J7. Okay, so at the top you expand. Okay, expand at the top. Okay, remember your square -1. Okay, then when you have complex number over complex number in rectangular form, we multiply the complex conjugate of this. So you have -3 plus J7, J7. Okay. We multiply the complex conjugate of this. So we change the sign of this, get a plus. When you multiply here, you need to multiply here. Because we want to remove the imaginary part at the bottom. Okay, then at the top, you expand as usual. And at the bottom, what you obtain will be -3 squared plus -7 squared. X squared plus Y squared. You will get X squared plus Y squared. Okay, but if you expand, okay, if you expand, you will still get the same thing. Yes. Okay, this one, we want to remove the imaginary part. We just need to multiply the complex conjugate of this. Okay, multiply the complex conjugate of this, which is this one. Okay, so this one, when you expand, you see when you expand, you get a okay, this one, when you expand, you get 9 minus J 21, and then plus J 21 minus J squared 49. So this one can be cancelled out with this. No more imaginary part. See, when we multiply the complex conjugate to the complex number, we can cancel out the imaginary part. And this is -1. -1 is it? Minus, we get a plus. That's why you have 9 plus 49. This one, 9 plus 49. So basically, this one, you can just straight away write 3 squared, 9. 7 squared, 49. No more imaginary part. Okay. Then, This one minus 112, you have negative 301. 441 minus 48 plus J 393. Okay. Any questions? Okay, proceed to C if you have done B. Okay, when you get a rectangular form over rectangular form, you have to multiply. Okay, we have to multiply the conjugate of this. You combine the real part and you need to multiply two. Combine the one in the bracket. Simplify. Simplify this one first. This one combined with this times 2. So this is how we multiply, divide, sum up, and minus in rectangular form. Okay, next one. If you look at the next one. Okay, now look at the screen. This question, okay, the complex number are presented in rectangular form, in exponential form, and also in polar form. So you can choose you want to run the operation in which form. So when we have the form of exponential and also polar form, it will be best we express all the forms in polar form. Okay, in polar form. Okay, this one, 2 plus J5. This one, 2 plus J5. You find for the R and theta. Okay, so this is the polar form of this complex number. So when we want to multiply this one with this one, okay, this means this one times this. This one in the polar form is this one. So this one, we also present this in the polar form. Okay, we have the 8 and 10. So polar form is this one. So remember when we have polar form times polar form, we just need to multiply the R. You get this? And for the theta, we just sum up the theta, you get this. Okay. Then we get the answer for the nominator. Okay, then we look at the denominator. Okay, denominator, this is plus. This is plus. When you do the plus and minus, we have to use rectangular form. Okay, rectangular form. That's why this part we have to change this into the rectangular form. The x plus j1. Okay, so this one, this is the denominator. This one, denominator here. Okay, this one remain. This one we change into rectangular form. So you see, r cos theta plus j r sine theta with r and theta here. Okay, once you have rectangular plus rectangular form, you just sum up the real part and imaginary part respectively, you get this. Okay, then this one we change into polar form because later we need to use this one divided by this one, right? Your nominator is this. This is your denominator. So for division, it will be easier if you run in polar form. So this one we change into polar form, which is this. So now you have this one, polar over polar. So R divided by R, you get this new R. And this one, you just use the upper one minus the lower one. You get this. Okay, so this is the division. Okay, so if you use this, this is much easier. Okay, much easier compared to the rectangular one. Okay, because for rectangular, you have to do this. You have to multiply the complex conjugate at the bottom and at the top. Simplify, then you get the answer. Okay. Okay, now we look at the second question. Okay, second example. Okay, this one all in rectangular form. Okay, all in rectangular form. Okay, we can evaluate this in rectangular form since all terms are in that form. Okay. So you have this one. Okay, nominator is j times 3 minus j4 conjugate. Okay, this one is the nominator. Okay, so conjugate will be 3 plus j4 here. Okay, then you just multiply, simplify, you get this. Okay, then this is the denominator. Okay, denominator, but here, okay, you can expand first and get one complex number, then only this complex number multiply to this. Okay, this one. And you just expand, simplify, you get this. This is your denominator. So that means we have this one divided by this. Okay, then you use this way. Okay. You can either use this or you change both into polar, then get the answer in polar form. You will get the same answer. Okay, now we try this. Okay, let's try this. So for question A, the denominator, you have polar and rectangular. But since this is a plus, okay, this is a plus, so we change this into rectangular form. Okay, we changed it into rectangular form because of this plus. Okay, so r cos theta plus j r sin theta. Change this into rectangular form, then you combine with this. And at the bottom, same goes to the bottom. This is a plus, okay, complex number plus another complex number. So we change this into rectangular form. Once you get complex number or complex number, you can decide you want to use rectangular or polar form to do the division. So you can change this into polar form. This one also in polar form. Then we do the division. Find for the R and theta directly from the figures. Not necessarily to be one. Okay, 2 or 3. Okay, I repeat once again, this one, we have different forms, but since this is a plus, so we change this into rectangular form. Okay, because of this is plus, we want to sum up these two. And same goes to this one. If this is a plus, no matter plus or minus, okay, no matter plus or minus, we have to use rectangular and rectangular. So this one, we change into rectangular as well. Okay. Once we get this, we combine real part with real part, imaginary part with imaginary part for the top and at the bottom functions. Then we get this. Okay, so this one, you can choose to multiply the top and bottom with the conjugate of this, or you can choose to change these two into polar forms. Okay, these two change into polar form. Then this one divided by this, you get this. This one minus this, you get this.
Cái đó. Cái được vô. You will take
You will get the same answer. Basically, you will get the same answer. Here, you get polar form, right? If you use the rectangular form, you get the answer in the rectangular form. But if you change into polar form, you will see that you get the same answer. They are equivalent. It is just presented in different forms. Okay. Okay, for those we have done A, you can try B. B is this is conjugate. Once you solve those inside the bracket, you have to get the conjugate as the final answer. Okay. Look at B. That's great. That's great. Okay, conjugate. Conjugate. Change this into conjugate. Okay, then you have to decide which form that you want to use. This one, you can use the polar form, right? Multiplication, then division. You can use polar form. Okay, so you can change all these three into polar form. If you want to continue with rectangular form, then you continue with rectangular form. Okay, if you want polar form, continue in polar form. Okay, here I will show you the polar form. All three rectangular form into polar form. Then this one multiply to this one plus this. Okay, same goes to the bottom. Then we solve the division. Then division.
What?
Okay, then finally, the complex conjugate of this is you just put a negative at the data. Kenapa tak juga kita nak dia remain dalam pola form. Sebab ini multiplication. Okay, okay, this question is different from this. This is plus, but this is multiplication. Multiplication. So it will be easier if you use polar. Okay, polar. Because this one times this, you get this. This one plus this, you get this. Okay, it will be easier because this is multiplication. Then we need to do division. Okay, division also easier. This one divided by this, you get this. This one minus this, you get this. And lastly, because of the conjugate, you just put a negative here. You just change the sign of the data.
Tolak. Ada pakai jawapan lah. Tolak. Jumpa apa
Division, data tolak. Multiplication, data dijumlahkan.
Oh, situ jumpa itu tolak.
Okay, any questions? Okay, we just look at the basic operation of the complex numbers. Okay, in the next class, we will look at the application. Okay, application. Okay, so if you have no more questions, we end the class here. So I will see you next Thursday, right? Next Thursday. Okay, so in between this, we will meet online. Okay, so this Thursday and next Tuesday, we have online class.